So NVIDIA just released a $4,000 gold cube that runs AI models with 128 gigs of unified memory while sipping only 240 watts of power. That is insane. But is it actually better than 4 NVIDIA RTX 5090s for AI workloads? So today, that's exactly what we'll be doing. We'll be diving deep into two completely different approaches to AI. NVIDIA's purpose-built DGX Spark right over here versus the absolute beast of a system that we have in the basement that is powered by 4 NVIDIA RTX 5090s. And by the end of the video, you'll know exactly which one deserves your attention. Now, before we jump into benchmarks, let's just talk about what these things actually are, because they are more different than what you might think. Yes, they both have CUDA 13, but that's not all that matters. The DGX Spark is NVIDIA's first consumer-grade graceful Blackwell system. It's got a 20-core ARM CPU, 128 gigs of unified memory, and a GB10 superchip all in one tiny package. So think of it as an Apple's approach with unified memory, but for AI workloads. So the whole system draws very less power. So it draws about 170 watts of power. It sips at the max 240 watts of power, which is their charger is rated at. Now 5090 is in a different league of its own. It's a traditional discrete GPU, meaning you need a separate CPU, motherboard, RAM, the whole 9 yards. It's got 21,760 CUDA cores, 32 gigs of DDR7 memory, and it pulls a massive 575 watts of power just for GPU alone, one GPU alone. And we'll be testing today 4 NVIDIA 5090 GPUs, so you can just do the math over there. So this thing is specifically built for gaming at 4K with ray tracing maxed out, but it's also become the go-to card for AI enthusiasts. Right out of the bat, we are comparing apples to oranges over here. One is a complete system optimized for AI development, and the other is a GPU that happens to be really good at AI alongside everything else that it does. For running these large language models, memory capacity is everything. The DGX Spark can handle models up to, let's say, about 200 billion parameters, Q4 quantized by itself. And you can chain two of them together and you can run up to 400 billion parameter models. And we're talking about when Llama did release a behemoth model with 400 billion parameters, and that is when the DGX Spark was actually announced. On a 5090, you are maxing out with only 32 gigs of video RAM for one. So around, let's say, 70 billion parameters with the lower quantization levels, you can fit over there. But if you add 4 5090s, then of course you will have the same amount of memory. Now, in terms of memory bandwidth, this is where the 5090 absolutely destroys DGX Spark. Now we are talking 1792 gigabytes per second versus just 273 gigabytes per second in DGX Spark, right? This is roughly around 6 times faster. This matters hugely for inference. And that's exactly what I need my AI for. Most of my work is done by my Jarvis server in the basement, and it only does inferencing. I do not generate a ton of images. I do not do a lot of video. Yes, I do some text to image generation for fun, but my major use case is inferencing, which is where this matters hugely for me. Power draw, though, is a different equation altogether. DGX Spark is incredibly efficient. It draws somewhere around 170 to 240 at max for the entire system, right? So even it idles around the 60 watts of power, 60 to 70 watts of power. And 5090, just by itself, one of it has the maximum power draw of 575 watts. And we are talking 4 of them. Plus, you add CPU, motherboard, and everything on top of it, and you are looking close to over 2500 watts of power over here at its full capacity. No, that's an apples to oranges comparison, right? So, in terms of price, so upfront, DGX Spark isn't a cheap device. It costs 4,000 US dollars, includes everything in it. 5090 on the other hand retails at 2K, but then we are talking 4 of them, so 8K over there. And then when you combine your CPU, motherboard, RAM, storage, power supply, case, and everything else, and you have to go high end over here because you need those PCI 5 bandwidths, you need at least a 4-slot motherboard, you need a CPU that can support these PCI lanes over here that can communicate. You don't need NVLink, you just need a high-speed PCI 5. So realistically, you are looking closer to 15 to 17K just for this bare minimum hardware to get things running over here. So the price difference is 4 to 5 times over here, what we are talking about. So specs are cool and all that, but how do they actually perform? So I've done a bunch of tests, and my favorite inferencing engine is llama.cpp, which is exactly what I'll be using today. So I'll be doing a ton of different LLM comparisons, inferencing comparisons, and where DGX Spark shines and where 4 5090s plus a huge system RAM that I have shines and outperforms. So let's get directly into it. Let me actually show you how small of the device this is over here, right? So I'm gonna switch to the side view right here. So you can see it is such a small device. It is definitely an AI supercomputer on your desk. A huge benefit of this device. Right, let me switch to a top view so you can see how it looks like over here, right? You see such a small form factor. I mean, yeah, it's smaller than my palm over here, for sure. So definitely a very, very tiny form factor. Something that I thought you guys will appreciate to see, that when NVIDIA calls it is an AI supercomputer on your desk, it 100% is. So 5090s, the rig, 4 of them, will not beat it in terms of its sound. It is dead silent. I cannot hear it. You plug it in, you press the power button, you do not even know if it is on. If you try to hear the fans kicking in, you don't hear them. Unless and until you are really pushing it to that 170 watts or 150 watts of power in that range. I did not hear the fans kick in over here, which is absolutely awesome too. So one huge win for our DGX Spark. Nothing beats it in terms of size. No, nothing in its class beats it in terms of size over here. All right, a quick thing before we do the performance comparison. I wanted to show you that this is actually a full-on Ubuntu machine. When you turn it on, it logs you into a full Ubuntu desktop experience, and you can see your system monitor with 20 cores of CPU over here. These are the ARM-based CPU cores, and if you want to see what kind of CPU cores they are, we can do an about search in the settings over here, which will show you exactly what kind of CPU cores we are working with. So we have Cortex X925, 10 of those cores, and Cortex A725, 10 of these cores over here, right? So these are the 20 cores that we see. We also have 128 gigs of unified RAM, which you can also visualize over here. There is a swap that is created of 18 gigs, 17 gigs over here. We have a disk capacity of 4 terabytes. And I have renamed the device as Spark for us over here. And you will see when I will SSH into the device while showing you the performance comparisons for LLM Inference, then this Spark name is what we will refer our device as. I've also downloaded few models on this device already, right? So I went to Hugging Face and I downloaded 4 models over there and moved them to this convenient folder, Dev AI models, GLM-Air. And my favorite model quantization level is UD-Q4KXL. So that's the GLM model. There is a GPT-OSS 120 billion parameter model of, again, UD-Q4KXL. And then we have a Magistral model, which is actually a full-on dense model. It is not mixture of experts. And this is on UD-Q6 KXL. This is one of the smaller models, and yet it is a denser model, so it will not run as fast, which is what we will see. And then we have Qwen-3, which is a 30 billion parameter model. But again, it is mixture of experts. So we have UD-Q4KXL, and I also have a UD-Q6KXL for this model over here. You'll notice I have 2 other frameworks, llama.cpp and llama.cpp already get cloned over here. And I'll talk about these 2 frameworks as well once we do the performance comparisons. This is a machine that you can just buy outright. It will come set up with your CUDA out of the box. So if you go in and you check for NVIDIA SMI, you will see that you have CUDA installed over here and you have the drivers installed over here out of the box. Nothing else is needed. If you do NVCC over here, then you will see that you have your CUDA version and your the NVIDIA CUDA compiler. Everything is all pre-set up. Nothing you have to install by your own. When we will look at our Jarvis server, which is in the basement, then you will see how everything was installed from scratch on that server. So both these servers, Jarvis and Spark, they are running Ubuntu 24.04 LTS version, and they are all on the latest version. The minor version over here too, which is pretty cool. We'll be able to do some apples to apples comparison with the same CUDA version, with the same operating system, and everything else should look familiar on both the machines, except for the fact that the form factor of DGX Spark and the form factor of our Jarvis server is just apples to oranges. All right, it's time to take a look at Jarvis now. So this is our behemoth of a server. As you can see, we have 112 CPU threads over here. And if you take a look at the processor, it says genuine Intel and then some kind of garbled text over here. This is because this is an engineering sample QYFS Sapphire Rapids Intel 4th generation server. Okay, the motherboard that we have is also an enterprise server grade motherboard. It is Asus Pro WS-W790E Sage SE, and I have done an in-depth review of this motherboard on my channel over here. We have the operating system exactly same 2403.3 LTS. We have 512 gigs of DDR5 memory over here, but all this is cool. What we actually want to see is our 5090s. So this is our 4 5090s that we will be looking at. Well, this machine has 5 5090s, but we'll be excluding the 5th one from our comparison and tests. So everything else on this system is exactly same. When I say that, I want to show you that there is llama.cpp in exactly same folder location, home dev AI, and there is models folder in the exactly same location. The same 4 models that you saw over there are also over here. So GLM, GPT-OSS, Magistral, and Qwen-3. And we have the UD-Q4KXL, which is what we will be playing around with. Okay, so now that we are done with both the machines' hardware setup, let's go and run llama.cpp on all these 4 models and just do a performance comparison. The way we are going to run these comparisons today is by having our DGX DGX Spark on the left hand side and our 5090 on the right hand side. And what we'll do is run llama.cpp in the terminals, both left hand side being our DGX Spark and right hand side being Jarvis. So, and Jarvis being the 5090 server that we have. So what else we'll do is on the project Gutenberg, there is this free ebook over here, and I'm just gonna download the plain text part of this ebook, and we'll use this as our context, right? We can copy a ton of text over here, and we'll just ask a random question to our LLMs by taking some text from here. Okay, I have already prepared a set of startup server commands actually that we will run in order for our llama.cpp to be up and running. So I have already git cloned llama.cpp, so we don't have to do that. I've built llama.cpp on both these machines using the commands that you can see on the screen over here, where you have to configure CUDA backend, and you build your llama.cpp, and then you confirm the server version, which is what we will do on both the machines. So let's just first of all log in. So we will do SSH over here, and left hand side being Spark and right hand side SSH being Jarvis. So you can see Mukul at Spark and Mukul at Jarvis. So these are our two different systems. Now on both the systems, our location of llama.cpp is exactly same. So now we are able to run the same command on both the systems over here. So let me just copy and paste this thing over here and copy and paste llama.cpp location over here too. And we can now run our server version to make sure that llama.cpp is built at the same server version over here. So I have just done a git pull and I have just built it on both the machines. So the server version is exactly same 6792 for both the machines over here, which is awesome. And we do recognize the 5090s over here. So we'll force our server command to not take into account this fifth 5090 whenever we are running our server over here. And I'll show you how we do that. Okay, so step number one, we'll use Qwen-3 A3B thinking model over here with 65K of context. We'll offload all of the layers. I think it has 60 something layers, but we'll just set it as a higher number, and we'll offload all the layers, utilize 16 threads of the CPU, and we'll just go ahead and we will run this. So let's copy this over here, paste this command over here. So this server still has 20 threads, but doesn't really matter. We're just gonna copy that, and we'll do the same thing on our Jarvis server as well. So both of them are going to run this particular model in llama.cpp. And the load time is approximately same over here. What did I do wrong? So if I start up the server with the same command on both of them, the problem is that it is going to take into account all the 4 or all the 5 GPUs on this machine. We do not want that. So I have done this on purpose to show you what actual command should be. So I'm gonna terminate the server on Jarvis, and then I will show you what the actual command should be that will force our llama.cpp to utilize only 4 graphics cards and not all 5 of them. So once I paste it over here, I will show you. So you see that I have done the CUDA device order PCI bus ID, and I have chosen to use 0, 1, 2, and 3. So only 4 GPUs over here. Now if I run that, you will see that only 4 GPUs, CUDA 0, 1, 2, and 3 are being used, and not all 5 GPUs are being used. So we are using 4 GPUs because we want to make sure we are assigning only 128 gigs of VRAM on our Jarvis server, and we already have 128 gigs of unified memory on our Spark server. Okay, so now what can we do? So these llama.cpp servers come with built-in web UI. So we can go to Spark 8001 over here, and we can go to Jarvis :8001 over here, and both of them will now render their web UI. And we can now copy same text from Project Gutenberg. So let's say we can just take maybe like some portion of the text. I don't even know how much it is. So I'm just going to copy some portion of the text, go to their chat interface and paste it both at the same time. And let's just, go ahead and send it and see what these two models do. So I'm going to do a send over here and a send over here. Okay. And you can see on the bottom over here that these models are now processing. They're working hard and they are processing. So, of course, we are done on the right hand side with Jarvis. We are already done on Jarvis server over here, and let's just go ahead and compare the performance. So we saw 2000 tokens per second for prompt processing. We had 3500 prompt tokens over here, and we got 72 tokens per second of token generation over here, right? And we got, wow, 5600 prompt processing on our 5090 server, and we got 175 tokens per second token generation over here. This is huge. 2.5 times performance difference straight up over here. Let's go ahead and have a little bit more fun over here. So I'm gonna ask what is the central theme of this, right? And I'm gonna copy this and I'm gonna paste this over here too and send over here and send over here. And I can barely hear some sound coming out of Spark now. So if you can see, 5090 is done. It's done. It's done processing already. Spark is still processing this right now. And it is almost done over here too. Okay, so Spark is staying around that 70 token mark over here, if you can see, whereas our 5090 is close to 200. So it is 3 times the speed over here. Let's ask one more question. Why do you think this is good? And I don't even know why it thinks it is good or not, but it's just ask the same question to both the models and just send it and see what happens. For some reason, this didn't even respond back. All right, so for first instance, our model didn't even respond back, but in the second instance, when I retried it, it responded back still faster. So it's 2 turns completed faster than the 1 turn of our Spark, right? So Jarvis definitely, as we already know that 5090 is a powerful machine. If the model fits on 15090, it will definitely going to make use of its all the raw horsepower that we get from it. Okay, so we are gonna just cancel this server. So Qwen-3, of course, we are seeing about 70 tokens generation and 213 token generation on our Spark and Jarvis respectively. Now let's go to the second model that we have. So the second model on our list is Magistral model. And this is actually a smaller model overall in terms of model parameters, but the activated parameters per token is way higher in this versus in our Qwen-3. So Qwen-3 is a bigger model as such. It is 30 billion parameter model versus Magistral being, I think, 24, 22. I'll have to double check that. But because concept of MOE kicks in, you will see that the token generation that we get on a smaller model, which is more dense, is definitely lower on our Spark over here. Okay, so both the models are now loaded. All we have to do is just refresh, reload, and reload. And we can just, send a hello over here and just, or we can just retry this whole prompt, right? So let's just regenerate and attempt to regenerate on both. And wow. Wow, so that's the difference between a 5090 and DGX Spark right there in front of you. Okay, it's done. We have 739 tokens per second for Spark for our prompt processing and only 10 tokens per second for our generation speed. As compared to contrast this with your 5090 over here, you have 3,932 tokens per second for prompt processing and close to 70 tokens per second for token generation over here. Definitely, it's an apples to oranges comparison over here. Okay, so we're gonna terminate these two servers as well over here, and then we'll go to some bigger models that we have, which is GPT-OSS 120 billion parameter. And let's just load these models on our servers now. So I'm gonna hit enter on the left hand side, and I'm going to hit enter on the right hand side on both these models, and they will start loading now. So because the size of these models is a little bit large, it will take a little bit more time for them to load, to read from the disk and to load. Okay, looks like Jarvis is almost ready. It is actually ready, loading the model for us. And our Spark is still attempting to read this particular model and load it into the memory. So we'll wait for a few more seconds. It has started to load it now. And we will give it a little bit of time to load this. So even though it has a pretty fast SSD in there, I think maybe because of heat or for whatever reason, it has slowed down a little bit in its performance over here. And my room right now is pretty cold and chill. So it is not the surrounding conditions that could be an issue. Maybe they could have made the device slightly more bigger, and they could have given it a beefier fan, because I can see that the device is probably struggling right now, but it is not kicking in, with its fan curve. It is very unaggressive. Let's just say that it's not aggressive at all. I would want the fan to be more aggressive than what it is right now. The model is still loading from SSD to the video RAM right now. Okay, all right, so the model is completely loaded now, which is good. So let's go ahead and let's have our let's ask at this time, summarize this in one short paragraph, right? So it will not write a huge bit of lines. Okay, so now we are gonna send on the left hand side, which is Spark on GPT-OSS 120 billion parameter, send over here. And then on the right hand side, we sent over here too. So you can see, holy moly, we are done. The 5090 is done already. Okay, and our Spark is done too. That was actually very respectable from Spark. So we processed about 6,000 tokens on left hand side and right hand side, right? So 6,500 tokens on both sides. For prompt processing, we got about 1,000 tokens per second on our Spark, whereas we got 3,700 tokens per second on our Jarvis server, right? So 5090s is still doing a pretty good job over here. The main difference that you see is in the token generation speed. You get 44 tokens per second on your Spark, whereas we are getting 190 tokens per second, close to 200 tokens per second on your 5090. Okay, so let's see. I copied some more of the text and I'm gonna send it over here and summarize in a short para. Let's just send this on the right side, and the same thing we'll do over here. Control V, summarize in a short para. Let's see both of them process this. Of course, um, the point I was trying to make is that slowly and slowly, once the context size increases, the models slow down just a little bit. So like at 10K context now or 9K context, you can see that the token generation has dropped down to 40 over here and 171 on the Jarvis. Okay, so we are done with our GPT-OSS comparisons. And the last comparison that I have is with GLM-Air. So let's just do that now. I'll paste the GLM-Air on the right side. And of course, I'm going to paste the command tuned for NVIDIA 5090s over here on the right side. So left side is our Spark, right side is our Jarvis. Jarvis is again loading the model super fast. That was pretty fast for Jarvis to load the model and get done. And that's a big model too, GLM-Air. It's a 100 plus billion parameter model and it is already loaded it and it is done. Whereas Spark is again, I think it has heated up, even though when I touch it, it is only like warmish. But I don't know. I cannot explain why the transfer is this slow. So the transfer from SSD to its unified memory, it is definitely slower. Of course, memory bandwidth and the transfer speeds do come into picture, but still, I would expect this to be faster than what it is right now. All right, there we go. Okay, so we have our model here. So let me ask it, summarize this in a short para, and the same prompt will go on the right hand side too. I will hit enter on Spark first, and then I will hit enter on Jarvis after. And we can see there are 14,000 tokens now. And Jarvis is done. Jarvis is done processing it. And our Spark is still processing the prompt. It is at 10, 12,000. Okay. And it hasn't started yet. So there we go. Okay. So it is now running it, and you can see it is doing a decent job. Like it is definitely fast with GLM-Air. GLM-Air's so even in mixture of experts, not every model that is mixture of expert is made equally. So your GLM-Air has a more denser expert as compared to GPT-OSS, right? That has only 5 billion per token, so 5 billion active parameters per token, whereas I think GLM has a higher number over here, which is why you can see that we only got 14 tokens per second versus we were seeing close to 40 for GPT-OSS. Okay. And if we do the comparison over here again, you can see our Jarvis server with 55090s has 2300 tokens per second, whereas we have 500 tokens per second for Spark. If you ask me whether is it worth it, so I don't know. I mean, I am spoiled by the amount of speed that I get from my 5 or let's say 45090s for the sake of comparisons over here. And the fact that I can run GLM 4.6 using my system RAM and NVIDIA GPUs, you know, that's something that I cannot do with Spark. Does it have a use case? Yes, it does, right? I mean, it sits on the desk. It serves the purpose, right? I mean, NVIDIA advertise it. It's an AI supercomputer on your desk. It can do a ton of LLM training, I mean, if you want to do it, has a lots of VRAM over here, which definitely helps with training instead of a split multiple GPU setup. So if you are into training, then definitely this will help. But if you are just looking for a very fast inferencing, no, I cannot recommend it. No, no. When will I be able to recommend this machine? If there is a cost constraint that you have, um, but even then you can go for M3 Ultra, right? I mean, there are, for inferencing, you can have a ton of, value coming out of M3 Ultra. There is the memory bandwidth over there will blow this machine out of the way, so there you go. There are also other AMD Ryzen AI Max machines that are coming out that you can spend your hard-earned money on. Would I recommend DGX Spark? Maybe yes, but only if you do not already have or are spoiled by some faster machines. Or if you want to run an even bigger model, right? Let's say if you want to run DeepSeek R1 Terminus model, DeepSeek 3.1 Terminus model. The Spark cannot run that, I mean, unless and until you quantize it to Q1 or Q2, maybe potentially. I don't think Q2 will run on this, but some weird Q1 quantization will potentially run on this, which will be of no value. I mean, the model won't be coherent for you. So it has a use case. I mean, it is kind of an edge device. I mean, sits on your desk again, right? How NVIDIA advertised it. So it has a use case, but I would much rather build my own AI server than use that one. All right. That is all that I have to say about the device. I know many people have made a ton of different videos on Comfy UI on this device, so you're more than welcome to watch those. And if I'll find some, I'll probably links in the description section. I'm not gonna be making a video generation on this or image generation on this. All that is, already out there. My final verdict: amazing device, feels awesome, doesn't make any sound. It is very low powered. It does what it is supposed to do. It can run GPT-OSS, that's the biggest thing. I believe that this device probably is made for right now for inferencing, because it can fit a large context and it can run that model pretty fast, right? It's made for a mixture of expert models, let's just say. Any bigger dense model, this will fail. Final verdict: it has a use case, just not my use case. Thank you everyone for watching this video, and please let me know what are your thoughts. Would you buy this machine? Do you think this has a use case for you? And if so, please leave a comment. And if you are all the way up until here watching this video, might as well go ahead and subscribe this video and this channel too. Thank you everyone.